Hi everyone, we are starting lesson 9 today. We're going to look more at the area of circles, and we are going to focus a lot today on this part of our learning goal right here, giving exact answers in terms of pi. The last couple days we've been working on finding the area of circles, but we don't give our answer in terms of pi. What we do is we round pi to 3.14. And that's okay in most instances. Sometimes, though, if we need to be exact, we have to use that symbol because that's the only way to include all the decimal places of pi. So let's take a look at some of those examples that I'm talking about. Here, in today's first activity, it says each square has a side length of 12 units. Compare the areas of the shaded region to the three figures. In the three figures, which figure has the largest shaded region? So, first it tells us that each of these squares is 12 by 12. That means that they're starting off with the same area. And that would be a good thing to identify here first. So the area of the square, which has has all four of the same side lengths, when we multiply the two dimensions of the square, 12 times 12, then we get an area for the whole square that is 144 square units. All right, so we're starting with the same area in A, B, and C. The difference is in figure A, we're taking this large circle out of it. In figure B, we're taking 4 smaller circles, and C, we have 9 even smaller circles that are being taken out. So if we're comparing the shaded region, what we're looking for is the area of this blue shaded part that's left after the circle's removed. Now, that would be very difficult to find the area of because it's not even a triangle when it has this curved side. So what we need to do is we need to use our understanding of area and our understanding of math to figure this out. We have found the area of the square. Now, if we don't have the shaded region of the circle anymore, we're going to remove that. We're going to subtract it. So we'll subtract out the area of the circle, and whatever's left is going to be the shaded region in figure A. So let's find the area of the circle. Now remember, to find the area of a circle, we need to multiply pi by the squared radius, or the radius times the radius. So that is what we're going to use to find the area of this first circle. The only thing we need to find, though, is the radius of the circle. Now, if we look all the way across this circle, that would be the diameter. And being that the circle goes edge to edge here on the square, whatever the side length of the square is will also be the diameter. Okay, if that's true, the radius is half of the diameter. So this square is going to have a radius from the center to the outside of 6. Now we need to square that. So we're going to multiply pi by the squared radius. If the radius is 6, then we're going to multiply pi by 6 times 6. So I could write that out, or I could just simplify that to 36, because 6 times 6 is 36. Now the best way to write this, here's where we're going to use our idea of in terms of pi. I'm not using 3.14 here. If I was, then I would just type into a calculator 3.14 times 36, and I would have my estimated area. But since we're doing our answer in terms of pi, the best way to write a number and a symbol or a variable being multiplied is to write the number first. So all we need to do is just flip this around, and the order in multiplication doesn't matter anyways. So we'll write this, instead of using 3.14, we'll write it as 36 pi. That is our exact area of this circle up here in figure A. Okay? Because we're giving our answer in terms of pi, we're done. That's our answer. So that circle has an area of 36 pi. Now, let's look at the rest of them and see how they compare, okay? Because we don't have to tell exactly what the area of the shaded region is. We're just asked which figure has the largest shaded region. So in turn, that means since we started with the same size square of 144 units, the bigger the area of the circle or circles that we're taking out, the less shaded region is left over. So let's see what we get for area of these 4 circles. They're all the same size. We're going to do the same process. And if we look across one of these circles at the diameter, you can see that the diameter of this circle is only half of the side length of the square. The diameter of this circle is 6, meaning the radius, which is half of that, would be 3. All right, now I'm going to save some of the work here because here we did the same process with our formula. We're going to square our radius, multiply it by itself, and then multiply it by pi. So for figure B, we're going to take 3 times 3, 3 squared, which is 9, and multiply it by pi. Now that's the area of one circle. We have 4 identical circles, so we need 4 of these areas. If the area of one circle is 9 pi, and we're getting 4 times more, then the area of all 4 circles combined is going to be 36 pi. That would be our total circular area. For C, we're going to do something similar. So let me use a different color here. If we look at the diameter of one of the circles, there's 9 identical circles here. So whatever we find for the area, we're going to be multiplying by 9. And if our side of the square, which is 12, has made up of 3 of the same diameters, 3 of the same numbers, then the diameter of the circle must be 4, because 4 plus 4 plus 4, or 4 times 3, will give me 12. Now if the diameter is 4, then the radius, which is half, is only going to be 2. So I'm going to square my radius. To get the area of a circle, I'll square my radius. 2 times 2 is 4, times pi gives me an area for one circle of 4 pi. But remember, there's 9 identical circles. So I'm going to multiply. 4 pi times 9 leaves me with a total of 36 pi. Believe it or not, each of these images, each of these shapes, has the same amount missing from the square. This large circle had an area of 36 pi. These 4 smaller circles did as well, and these 9 of the smallest circles did also. If the same amount is missing from that same size square, then all of the areas of the shaded region are the same. There's no difference in any of the 3 pictures. All right, let's take that idea on here. So here we have 2 different shapes. It says each square below has a side length of 1 unit. Compare the area of the 2 figures. Which figure has more area and how much more? Now here, because we're asked which is more area and how much more, we're going to have to be precise. So we may not want to do this in terms of pi necessarily. We could, but let's just kind of try and see where we go. So if we look at figure D, we're going to have to kind of break this shape down into shapes that we know how to find the area of. We are told that the square has side lengths of 1. I see a square here and here. So if I recreate this image, kind of breaking it apart and show what we have our 2 squares there. And then notice that we have these curved shapes, and with this dotted line that's going through the center, it's showing us that it's a half circle. Now we have 1, 2, 3, 4 half circles. So if I were to draw a circle made up of 2 halves and another made up of another 2 halves, this would show a combined set of half circles. 2 half circles makes a whole circle. So this is another way to represent the area of this weird shape. Now let's look here. I see that we have 4 squares through the center here. Let's see, let me do a different color. So 4 squares. And then looking at these unusual shapes here, we have quarter circles. If we had a full circle split like this, see how a quarter circle is what we are dealing with here in this piece. And we have 1, 2, 3, 4, 5, 6 quarter circles. Well, only 4 quarters makes a whole circle. So I'm going to also need another half of a circle. So we're missing the other half here, but another half of a circle to use my other 2 quarters. So I still have 1, 2, 3, 4, 5, 6. I still have my 6 quarter circles. I've just combined them into making a full circle and a half of a circle. Okay? Now, we can do a little elimination here and try to solve which has more area. It's not necessarily easy to see right here because we're dealing with different shapes of different sizes. So this, I think, would be a good time to use 3.14 for pi. Let's find the area of these circles and get an approximate amount for how much bigger one shape is over the other. So if we're told that the squares have a side length of 1 unit, if this square is 1 by 1, then its area would be 1 square unit. 1 times 1 equals 1. I'm going to get the same thing here. So for the second square, it's the same size, and all these squares are going to be the same size. So if I look at figure D, the 2 squares give me 2 square units. And figure E has 4 square units. And now I just need to calculate the area of the circle. So let's look back at the image here. If this square has all sides as 1 unit long, looking at this side here, this would be the center point of my circle. Imagine this upper half circle sliding over to make a full circle here. So we'd be looking at a circle like this. If you can see that, you can see that the side of the square is the radius of the circle. So the radius of the circle is 1. All right, if the radius of the circle is 1, remember how we find the area of a circle. We multiply pi. Actually, in this case, we're going to use 3.14 times the radius squared. So taking our radius of 1, 1 times 1 is still 1, and 1 times 3.14 is 3.14. So the area of a circle, is 3.14 in this example. The circles are the same size in image E as well. So if we have two circles, we have two of these areas, and two 3.14s, or 2 times 3.14, is going to be 6.28 square units, and that's from the circles. To get a total, we're going to have to add that all up, and we'll get 8.28 square units. And that would be our approximate area, because it's approximate because we used our estimate for pi. This is our approximate area for figure D. Now let's check how many circles we had in figure E. Remember, we had 1.5 circles. So we'll have 1.5 times 3.14. And that will add 4.71 square units from the 1.5 circles. And if we add that all up, we'll get 8 71/100 square units. And you can see now, based on our calculations, figure E is larger, but not by much. If we wanted to be exact, we would just subtract. So go ahead and subtract the smaller image, the total area of the smaller image, from the total area of the larger image. That answer, that difference, is going to answer the question, how much more, how much bigger is figure E? All right, now let's look at our last bit here in the handout. So this is, again, kind of reviewing that in terms of pi idea. The first one asks, what is the area in terms of pi of a circle with a radius of 10? Now, because our formula for area is pi times radius squared, if I'm given the radius, there's nothing else I have to find about this circle except to answer the question, which is calculating the area. So let's take the radius, which is 10. This is not going to require a calculator. That's the nice thing about working with in terms of pi. If the radius is 10, I need to square it. I need to multiply it by itself. 10 times 10 is 100. All I'm going to do with that squared area, so 10 squared equals 100. All I'm going to do with that squared radius is multiply by pi. And if I keep it in terms of pi, I just need to put the symbol next to it. So my answer for the first one here is 100 pi. Easy. No calculating, no rounding decimals. That is a very exact, precise area for this circle that has a radius of 10. Now let's look, what's the area in terms of pi of a circle with a diameter of 10? Well, a diameter of 10, remember, goes all the way across the circle, which would mean that the radius is half of that. The radius equals 5. Let's square that radius and then multiply by pi so we can find the area of the circle. Now, if our radius is half the size, is our area going to be half of what it was here? Hopefully you're saying no, because remember, area is not a proportional relationship. If we're getting half the radius, we're not going to get half the area because this is not a proportional relationship. We have an exponent in our equation. But let's figure out what it is. So our radius is 5. 5 times 5 is 25. So the area of this circle is 25 pi. 25 times pi. And lastly, we're finding the area of another circle in terms of pi. Oh, actually, it's a half circle with a diameter of 10. So the radius is still going to be 5. Now we're talking about the same circle here because we have the same radius. The difference is we're only going to find half of it. So if we have the same diameter, the same radius, the area of the whole circle is going to be 25 pi again. If I only need half of that area, this is easy. I'm just going to take half of that area. I don't want 25 pi. I want 12.5 pi, because 12.5 is half of 25. All right. Now, on the back of your handout is some practice on this skill. Now, it is going back to a couple of shapes that we haven't worked with for a few lessons. The first one, though, is a great example of where you're going to find a larger area and then remove part of it. Remove this half circle. So find the area of the rectangle, find the area of the whole circle, but then we're only going to actually subtract half of that area because half of a circle is missing from the rectangle. All right, what I also wanted to review is finding the area of a triangle. Remember, for the triangle, we need to know those two perpendicular measurements. So the base and the height is what we would call it with a triangle. And if we multiply to get the area of a triangle, we take the base times the height, which gives us too big of a shape. We only want half of it. So divide it by 2 or multiply by half for the area of that triangle. Then you're going to need to also find the area of some circles, some rectangles, some squares. Remember from our lessons, you can break the shape down into smaller shapes, or like we talked about with this example here, find the oversized or the complete rectangle and then remove part of it, subtract part of the area. All right. Check for the answers in the notes to follow, and please get on Zoom with any questions. Have a great day.